Guys, welcome back to howmachineworks.com. Joe's here. Today let's learn how a axial flow piston pump works. So this is a dismantled view of the axial flow piston pump. Let's identify all the internal components and learn its working. So those are the pistons arranged over there. See the pistons actually protruding outside the cylinder block. Okay, and that's a swash plate over there where the pistons actually slide. So this is a variable type pump. That means the flow can be varied, normally used in track excavator machines. So those are the pistons. You can have a closer look over there. And what I'm rotating is the cylinder, and on the left side we have the drive shaft. The drive shaft and the cylinder is a single unit. That means the drive which is reaching the drive shaft will result in the rotation of the cylinder, and inside we have these pistons which actually move. So when the swash plate is vertical, there is no flow, and as the swash plate angle changes, that's a swash plate over there, as the swash plate angle changes, the flow varies depending upon the angle of the swash plate, and the swash plate angle is controlled by a valve according to the load and the requirement. So that's the rear side of the piston which is connected towards, or which is sliding over the swash plate over there. Okay, now let's go and have a closer look and identify each components over there. That's the drive shaft, which is a part of the cylinder itself. The drive shaft gives drive towards the cylinder, and that's the swash plate, which I told the pistons are resting and sliding over. The swash plate angle changes, the flow varies. That's our cylinder block in which we have the pistons arranged, and as the cylinder block rotates, the pistons slide over and actually reciprocate. That's the pistons over there. We have many number of pistons which are arranged inside a particular cylinder block. So that's the front view where we have the inlet and the outlet. The top we have the discharge, and bottom we have the suction. So you can see the angle how it can be changed on the swash plate, and when the swash plate is vertical, as I told, there is no flow. If you need to see the animation to get a precise understanding of its working, there is an annotation over there. Click on the annotation and see the animation of the axial flow piston pump. Okay, watch the full video and go to that. So that's I already showed the rear view over there. That's actually resting on the swash plate. Now let's remove the pistons outside. So those are the pistons being taken. So the o-ring gone down, I think. Okay, we have the pistons over there. We have many number of pistons which are inserted into the drilled hole inside the cylinder. You can see the shaft and the cylinder is a single piece over there. The drive shaft is directly connected towards the cylinder at that section. Now you can see that the pistons over there which I have shown, and these are the holes where the pistons will actually be inserted, right? Okay, now you can see the cylinder once again and the different angle of the cylinder. Now we'll be keeping the piston back into the cylinder block, and let's see how it can be assembled back. And make sure that when once it is removed, it should be given back into the same pot and should not be changed, because they have already mated, and scoring marks will be like a male female scoring mark, so it has to be inserted in the same pot. So that's how it looks. As I requested, make sure that you click the annotation and see the animation video also to get a better understanding of the working of the piston pump. And also make sure that you click the subscribe button so that daily video updates will come to your inbox, because we'll be uploading more technical videos. So here you can see how the pistons actually move as the cylinder rotates. Both the drive shaft and the cylinder is rotating. At the bottom, the piston is moving back, which is creating a suction, and moving towards the top, the pistons actually reaching the maximum suction, and as it rotates to the other side downwards, the delivery is happening. You can see the piston movement inside the pot of the cylinders very clearly over there. Have a closer look over there, and that's how it exactly works. The change in swash plate directly affects the flow. When increasing the angle, flow increases. When decreasing the angle, flow decreases, because when the swash plate is vertical, there is no piston movement, that is, there is no axial movement of the piston, and no flow is happening. So as I requested, please subscribe, like, comment, share to motivate our team. You can also see the description for more detailed links. Thanks for watching this video. Have a great day. Hi guys, welcome to howmachineworks.com. Today, with the help of the animation, let's learn how a plunger pump exactly works. It's a reciprocating tape pump, and also it's a positive displacement pump. First, we'll identify all the components, then we'll go into the animation and learn its working. So let's see the components. That's the head and the body of the pump. You can also see the internal galleries very clearly there. Then we have the plunger. This is a reciprocating part of the pump. Then we have the connecting rod which connects towards the drive rotor. That's the drive rotor over there. Then we have the valve springs, and that's the fluid inside the pump, and those are the valve balls which closes the valve port. Now let's see how it exactly works. See, the rotor gets a drive and it rotates. When it rotates towards the top, what happens is that the plunger reciprocates towards the front. As the plunger reciprocates towards the front, a pressure is created both towards the inlet and outlet valve. So the flow is created over there, and that goes and hit both the valves. First it hits the inlet valve, you can see, and it closes the inlet valve very firmly, and the inlet is firmly closed. And when it hits the outlet valve is pressured and it opens up. And as the outlet valve opens up, the oil can escape over there. You can see further the rotor is rotating and the plunger moves further towards the front, which pushes the oil outside through the outlet. So that's how the discharge is happening in a plunger pump. This is called as a positive displacement pump because whenever it rotates there is a discharge. Now further it moves backwards. You can see further as the rotor rotates, what happens is that the plunger is now moving towards the backward direction. So a low pressure is created at this point, and that creates a suction. Now the suction is happening. So you can clearly see the suction is happening over there, and as a result of that, it creates a suction force on both the valves, and that helps the inlet valve to open up over there. The inlet valve opens up and oil enters through the inlet valve, and that's carried away into the actually into the body of the plunger pump itself. So that gets into the body of the plunger pump, but the outlet valve will be closed at its condition. Now further the rotor rotates and the plunger moves backwards again, and the pressure, the suction force, the low pressure further increases and the suction further increases, for more oil is getting inside towards the plunger pump. At this time the discharge of the outlet is firmly closed, but the suction is happening. And the same process continues as it rotates further. You can see the plunger moves towards the front, it pressurizes the oil, inlet is firmly closed, outlet gets open, and the discharge happens, and the plunger further moves towards the front, more amount of discharge is happening. So this is how simply a plunger pump actually works. I believe you understand the working of it through this animation. So we'll be uploading more technical videos on a daily basis. So please click the subscribe button for getting updates. You can click the like button, share or comment to motivate our team. You can also visit our website or our YouTube channel for more such technical content. Thanks for watching this video. Have a great day.
This is a Wilden PX 1500 76mm 3-inch advanced aluminum pump. The liquid chambers are alternately filled and emptied by fluid that is drawn through a common inlet and discharged through a single outlet. The diaphragms in each chamber are linked by a single shaft, allowing them to move in unison. The air valve directs pressurized air to the back of diaphragm A. This begins chamber B's suction stroke, which starts as diaphragm B is moved toward the center of the pump, thereby creating a vacuum in chamber B. Atmospheric pressure then forces fluid into chamber B past the inlet ball valve. When the pressurized diaphragm A reaches the limit of its discharge stroke, the air valve redirects pressurized air to the back of diaphragm B. This begins the discharge stroke of chamber B. The hydraulic forces developed inside of chamber B force the inlet ball onto its seat and the discharge ball off its seat. This condition allows fluid to flow through the pump discharge. The same process occurs in the opposite chamber, constituting one full cycle. The pump will continue to run until inlet air supply is interrupted or discharge pressure rises to equal that of the air inlet pressure.